In this video, we'll take a look at a vintage radio, the Allied Radio Shack SX-190 shortwave receiver. The SX-190 is a solid-state 11-band shortwave radio receiver made by Radio Shack from 1971 to 1973. Early units were branded as Allied, reflecting the merger of Allied Radio with Radio Shack in 1970. Later units like this one had Radio Shack's realistic house brand on them, as well as RS for Radio Shack. The radio typically retailed for US $249.95 in Radio Shack stores. The optional matching SP-190 speaker could be purchased for an additional $19.95. Also offered was the model AX-190, which was identical except that it covered amateur radio rather than shortwave broadcast bands. The radios were manufactured for Radio Shack in Japan by a contracting company called GRE. The SX-190 covers 9 shortwave radio bands, each 500 kHz wide. The bands covered are 80 meters from 3.5 to 4 MHz. This includes the 80-meter amateur radio band. 49 meters from 5.7 to 6.2 MHz. 40 meters from 7 to 7.5 MHz. This includes the 40-meter ham band. 31 meters from 9.5 to 10 MHz. This can pick up time station WWV at 10 MHz. 25 meters from 11.5 to 12 MHz. 20 meters from 14 to 14.5 MHz, which includes the 20-meter ham band. 19 meters from 15 to 15.5 MHz. This includes WWV at 15 MHz. 16 meters from 17.5 to 18 MHz, and 11 meters from 27 to 27.5 MHz, which includes the US Citizens Band. 2 additional optional bands can be covered by installing suitable crystals in 2 provided crystal sockets. One can be in the 3.5 to 10 MHz range and one from 10 to 30 MHz, and each covers a 500 kHz segment. You could order crystals for $6.95 each from Radio Shack or obtain them yourself from another source. It's a solid-state design employing 4 field effect transistors, 22 bipolar transistors, 13 diodes, 2 Zeners, and 2 thermistors. It can receive AM, single sideband, and CW or Morse code signals. Sensitivity is better than 0.5 microvolts on single sideband and CW and 1 microvolt on AM. Selectivity is 4 kHz at 6 dB down. It features analog tuning with a dial accuracy of plus or minus 200 Hz. It's a dual conversion superhit design with a first IF of variable frequency from 2.42 to 2.92 MHz and a second IF of 455 kHz. It's powered by 120 volts AC at 60 Hz. There was a European 230 volt 50 Hz model, or an external 12 volt DC power supply. Power consumption is about 10 watts. It requires an external speaker and can deliver a maximum of 1 watt of audio output to an 8 ohm speaker. It also features an 8 ohm headphone jack. It has a 50 to 75 ohm unbalanced antenna input, and the rear panel has a remote standby input for use with a transmitter. Other features include a Q multiplier with variable frequency and band pass and band reject modes, a 25 and 100 kHz crystal calibrator, automatic gain control or AGC, switchable diode type automatic noise limiter on AM, and an S meter. The rear panel controls and connections are, from left to right, 8 ohm speaker connection, audio output for a tape recorder, VFO output used during alignment and test, standby input for use with a transmitter and normally jumpered if the radio is used on its own, AC-DC power source selection switch, 12 volt DC power input, AC line cord, AC line fuse, HFO output, again used during alignment and test, ground connection, and antenna input. On the front panel, the controls and connections include, from left to right, headphone jack, pre-selector control used with the dial above it, band select switch, 25 and 100 kHz calibrator controls, main tuning, The frequency is indicated on the dial above as well as on the dial markings. Q multiplier tuning and mode select controls. AF and RF gain controls on the same concentric shaft. Mode select, upper sideband, lower sideband, standby, AM, and AM with automatic noise limiter. S meter at upper right, and power switch. I'll go over the basic usage of the controls later in the video. The case is quite heavy and all metal. The machine knobs are solid aluminum and of high quality. It uses metric hardware, and the workmanship is typical of Japanese radios of the 1970s. Looking inside, the circuitry is on 6 printed circuit boards with some additional point-to-point wiring. It uses single-sided phenolic PCBs with silkscreen and solder mask. From the top, the circuit boards are IF amplifier, VFO in a shielded compartment, crystal calibrator, audio board which also has some power supply circuitry, and RF board. There are 4 small dial amps illuminating the preselector and main tuning and S-meter dials. Tuning uses pulleys and dial strings as well as some gears in the VFO to implement vernier drive. On the underside there's additional power supply circuitry and the buffer amplifier PCB, which is inside a shielded cover. Basic operation is as follows. Turn on the power switch, set RF gain to full and AF gain to a suitable level. Select the band and mode. Adjust the preselector to the maximum noise level near the frequency indicated for the selected band. Tune the desired station and adjust the volume as needed. The frequency is the base frequency of the band plus the reading on the dial. More accurate frequency can be read off the indicators on the tuning dial once calibrated. AM uses the center marker, while upper sideband and lower sideband modes use the markers on either side. You need to adjust the preselector for maximum output when tuning is changed. This is more critical on the higher frequency bands. You can reduce the RF gain on strong signals and turn on the noise limiter on AM if desired. Here I'm picking up an AM shortwave broadcast station on the 11.5 megahertz band. This is some ham radio stations using single sideband mode. And here's some amateur radio communications using Morse code. I can usually pick up time and frequency station WWV at 10 and 15 megahertz. This provides a very accurate frequency reference that can be used when aligning the radio. An advanced feature usually only seen on expensive receivers is the Q multiplier. It provides a sharp bandpass or band reject filter which is useful for selecting one signal out of others, typically Morse code, or for filtering out an undesired station. In reject mode, the tuning control selects the frequency or station to be filtered out. In select mode, tuning controls the frequency to be selected and others are filtered out. This feature takes some practice to use, but is particularly helpful when receiving Morse code stations that might be close in frequency. Note that the tune control is for the Q multiplier only and performs no function when the Q multiplier is off. I bought this radio at an estate auction run by a local radio club in July of 2023. I also bid on a couple of the matching speakers, but was outbid. While quite dusty, the radio looked complete and original. On the internet I found the operating and service manuals, as well as some reviews and articles on modifications for the radio. It seemed to work when first powered on, although the controls and switches were a little noisy and intermittent. I did a light cleaning inside and out, lubricated the controls, and used contact cleaner on the switches and pots. The dial skirt was stuck to the tuning dial. I removed and cleaned it. As mentioned, there are two optional custom frequency bands with corresponding crystal sockets. There was no crystal in the X1 socket, but the X11 socket had a 23.92 MHz crystal. This corresponds to the 15-meter amateur radio band covering 21 to 21.5 MHz. A Dymo type label marked 15 was in place. I removed it as well as another label and used a label printer to make a label marked 21 that's similar to the markings on the band switch. I replaced the 15 or so electrolytic capacitors with new ones. As far as I could tell, none of the old ones were bad. I didn't test them, but they were about 50 years old and likely to fail. I used tantalum types for some of the lower voltage caps as I had them on hand. I went through the alignment procedure. It's quite long, 7 pages, and the instructions in the service manual are quite terse and contain a few errors. I wouldn't recommend performing alignment unless you're familiar with the process. Alignment requires a signal generator, oscilloscope or AC voltmeter, and preferably a frequency counter. It makes use of the crystal calibrator and VFO and HFO outputs. You need several different alignment tools to adjust the trimmer caps, coils, and transformers. I did some minor touch-up of the adjustments, which didn't seem to make any significant difference in performance, but got the dial reading more closely aligned with the correct frequency when using the crystal calibrator. A number of articles have been written over the years which suggested modifications and tricks. None of the mods seem particularly critical. They include such things as making the S meter less sensitive and adding a tone control. As it's not a general coverage receiver, it can normally only pick up signals on the specific bands that it covers. Some users have discovered that by deliberately mistuning the preselector, you can receive other frequencies. You can find details in articles on the internet. The pilot lamps are small incandescent bulbs. Mine were all working, but if they were to fail, I would consider replacing them with white LEDs. They would have a longer life and would significantly reduce the power consumption, as the dial lamps actually take more power than the rest of the radio. The SX-190 was Radio Shack's most expensive and sophisticated shortwave receiver. It received generally good reviews at the time and was considered a good value for the money. These radios appear regularly on auction sites and at flea markets. If looking for one, be aware of the similar-looking AX-190 model with different band coverage. It's still quite an adequate receiver for shortwave listening, and no doubt many are still in use.